Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. This week we are learning about the set of compounds called as resins. We saw what are resins, what are different types of resins. When coming to examples, we saw examples of resin containing drugs such as colophony. Then we saw benzoin, which is an example of balsams. In the previous session, we saw examples of oleogum resins, examples of which included your guggul, myrrh and asafoetida. In this particular session, we will be dwelling into more interesting set of resinous compounds. Now this resins what we discuss in this sessions are the ones that we consume on day-to-day basis. So the three oleoresin gums which we are going to discuss today are your ginger, turmeric and your chilies. So ginger, turmeric, capsicum or chilies, what they have common in them is as compared to the previous ones. When we discussed, we said oleogum resins are resin combination which contains essential oils, carbohydrates and resins. Now these three drugs do not contain the carbohydrate element. That means they are combination of two moieties and these moieties are your resins and volatile oils. So let's see one by one of all these three and how these oleoresins are therapeutic and beneficial to them. The first case is your ginger. Now ginger we all have seen in our kitchen is actually a rhizome. Now this rhizome may be scraped or unscraped. That means the outer cork of it might have been removed or it might be intact. In India, very often we consume fresh ginger and as a result when you buy your ginger from market, you will find that it already has its cork. But due to cold conditions, some countries it is not possible to cultivate ginger. In such cases, in order to preserve ginger, they often have it decorticated for long-term storage and to prevent the nodes from developing into a new plantlets. So ginger belongs to a plant called as Gingiber officinale, which comes from the family Gingiberaceae. Now the Gingiberaceae family members has numerous rhizomes which are very rich or which have been used in culinary such as your galangal, turmeric, but Gingiber officinalis is more often referred to as your ginger. So in BP the unbleached ginger is officially the Gingiber officinale and the plant part of the ginger which is used is the rhizome. Now geographically ginger has been cultivated in most of the tropical to temperate climates. This includes the islands of Jamaica. In African subcontinent we have ginger abundantly being cultivated in India as well as in China. Now when you procure your ginger from these sources, there are slight difference in the color, in the shape and in the morphology of these three ginger sources. Not only that, they also differ in the pungency. So there's a good variation or geographical variation even in Gingiber officinale which has been obtained from different geographical sources. Now once you cut the ginger, now this ginger also comes under the category of or what you call it as a prepared resins. So when we did our first session on resins, we said you have natural resins and in some cases you need to have what are called as prepared resins. The reason why we need to have prepared resin is, if you cut a ginger by knife, at no point the resin is going to exude out. Now there is a reason for it. So I can show you in the diagram. So this is what I call it as a microscopic section. So if you take your ginger and slice it thin and put it under microscope, this is what it is going to appear like. Now this if you observe carefully, mostly is parenchymatous in nature, and within this parenchymatous nature, if you see this yellow dots, these are the ones which store oleoresin. So this is oleoresin cell into which your ginger oleoresin has been accumulated. So if you cut it, it is not possible that every time you cut a cell and it's going to leach out, and as a result, in order to extract this resin out of ginger, it is essential to dry the ginger, powder or pulverize it, and thereafter extract it in a suitable solvent. Now this suitable solvent can include anything between alcohol to hexane, and in some cases or industrially, ginger oleoresin has also been procured by a process called as supercritical fluid extraction, where your supercritical carbon dioxide is used to extract this from the ginger powder. So if you see your ginger comes under the category of your prepared resin, and if you see the combination, it is a oleo resin combination. So ginger, how do you procure it? So mostly if you see this ginger, you see numerous buds out here, or we often refer to as fingers. So these buds are often cut off if you want to propagate the plant, and then they are planted during the summer season, okay, with a good dry soil, and then they are watered. Now once during the rainy season they start giving you big leaves, and eventually some of them bloom, okay. After blooming they start withering off, okay, and it is seen that especially during the winter season, initially the leaves will turn yellow and gradually they wither and dry. It is during this time that the stems are carefully cut off and the rhizomes are dug. Now during the process of digging, again the care is taken that the rhizome is not damaged. It is lifted almost in a very intact manner, washed nicely, and then dried in sun. Now in some cases, when you want to preserve your ginger for a longer duration time, now what happens is, if you keep these fingers or rhizomes of ginger in a good moist place, you will see they gradually develop stem. We don't want that to happen if you want to store it for culinary purpose. For cultivation, that is fine, but for culinary we don't want it to grow into a new plant. And for this reason, when I want it in commerce for preparation of resins for culinary purpose, what is done is this ginger is taken and boiled. This boiling often renders the ginger sterile and incapable of any further growth, and as a result you will see the ginger will stay intact. So it is blanched or boiled, and after boiling what happens is, in some cases you will see the cork comes off. Now in Indian culinary we take the unboiled naturally obtained ginger which has been dug off, but like I said, for commerce, when you want to export it to the colder countries and you don't want it to germinate during the shipment or during the storage period, what you can do is you take the ginger, boil it or blanch it, gradually remove the peels to ensure that there is no budding or no growth happening in the ginger. Now once this boiling is happened, it will tend to deteriorate or ferment, and as a result, it immediately after boiling it is dried. Now it may be tray dried or it may be dried in sun for a period of 5 to 6 days. Now in some cases during the boiling, because of heating, like I said, some processes such as browning start, because it contains good amount of starch. So to take care of the color, what is done that it is observed that if you reheat it, that is reboil it and again re-dry it maybe 2 to 3 times or so, you will see that in that case the ginger is more whiter and more aesthetic as compared to a singly boiled ginger. So this is how your ginger is prepared, but in addition to it there are numerous other processing methods which include sun drying. So you can directly take your ginger, peel it from the cork or peel the cork and dry it in ginger and supply it as such. In some cases it is dried in oven directly. in places which are moist or damp throughout the year, it is not possible to dry the ginger under sunlight because that dampness will not allow the moisture to evaporate. In such cases, artificial heat is used, and the best condition is to heat it in a tray dryer at a temperature not exceeding 60. It is said that 60 is a good temperature. At any point of time, if you exceed a temperature over 70 degrees Celsius, your ginger starts to brown, and as a result a temperature over 70 degrees Celsius is not desired. Another way of saving ginger, which is often done in Indian household, is you take a fresh ginger, wash it properly and scrape it with a scraper. So when you scrape it, the peels or the skin of it are removed, and you need not bleach thereafter. You just need to keep it in a cold conditions. Nothing will happen to your ginger. Now when it comes to long term storage, few processes like bleaching or liming is done. Now what is the bleaching and liming process? Now after boiling, in some cases the ginger is soaked in lime water. This gives a good appearance to ginger. It appears more white and often referred to as lime ginger. But if you see the official source, as we discussed, BP, the official ginger is what is referred to as your unbleached and unlimed ginger. So that is not used in therapeutics, but that can be used for your culinary purpose. So it is used in lime, and in some cases when you want a container or a shipment storage, it is also fumigated. So the fumigation is done mostly with sulfur dioxide gas. So in a very enclosed container space, so that the gas stays for a while and permeates inside the ginger. This also prevents the growth of bacteria, fungus, molds on the surface, as well as prevents any growth thereafter. So you can lime it, you can bleach it with your sulfur dioxide, or you can have a combination of both, that is fumigate it with sulfur dioxide and subsequently dry it, lime it and save it. Now another additional way in which your ginger is prepared is to extract the oleoresin out of it. So in cases where you don't want a large quantities of raw material to be transported, the main flavoring principles of ginger lie in the resin. We just saw those tiny greenish dots inside the ginger. So we can extract it by solvents including your ethanol, hexane, or even, like I said, supercritical fluid extraction. Concentrate those extracts, and those extracts are directly shipped as your ginger flavor. Now what exactly imparts the flavor of ginger? We'll see the chemical composition. Now the oleoresin of ginger contains almost 1 to 2% essential oil, and most of the resinous composition are the mixtures of your phenylpropanoids and their derivatives. So if you see your volatile oils, your volatile oil contains somewhere like your philandrine, especially your beta philandrine, camphene, cineol, citral, borneol. They contain little bigger compounds which are more fragrant and responsible for the aroma of ginger. This includes your gingiberin, which is the main flavoring principle and aromatic principle of ginger, bisabolin, farnesin, then you have your beta sesquiphilandrin or curcumin, and other sesquiterpene alcohol, which includes your gingiberol and gingerdiol. So this sesquiterpenes are the main compounds which are responsible for like the aroma as well as flavor of your ginger. But in addition to that, you also have compounds such as gingerols and gingerones, ABC, as well as isogingerones. So if you see your gingerols here, gingerols are typically phenylpropanoid derivatives. Take for example 6-gingerol. So 6-gingerol is, if I cut it like this, you will see a phenylpropanoid out here. So this is your phenyl. This is your 1, 2, 3 propane. And now when I cut this, I just start numbering from this carbon. So 1, 2, 3, 4, 5 and 6. So wherever this hydroxy is, you get the gingerol gets its name from this. So this is an example of 6-gingerol. Again, if you see your 8-gingerol, you have a phenylpropanoid moiety out here. But if you see hydroxy position, you will see here 1, 2, 3, 4, 5, 6, 7 and 8. So here hydroxy is at 8 position. So you have your 8-gingerol. Similarly, you will have your 10-gingerol. You can just do the counting and you will see it matches. So 6, 8, 10 gingerols. Now it is seen that this plant on during the stages of its preparation, the gingerols undergo dehydration. That means they will lose a water molecule. So imagine they are losing a water molecule like this. So I'm losing this HOH, and as a result it leads to formation of a double bond out here, and these compounds are called as chagols. So chagols originate out of gingerols basically by a dehydration process. Now, in some cases, when you want your ginger for culinary purpose, if you consume your ginger, it's extensively pungent and spicy. The spiciness of the ginger can be decreased by removing these compounds. So if you see your gingerol, you can destroy your gingerol by treating or boiling it with 2% potassium hydroxide. Similarly, if you see the same compound, I just break it from here, and that is what is called as your gingerone. This gingerone also is destroyed if you put a little concentration or little higher concentration, that is about 5%. If you take sodium hydroxide and heat it or keep it in prolonged contact with your ginger, that pungency of gingerone also vanishes. So your gingerols and gingerones can be treated or kind of inactivated, and the pungency of the ginger can be destroyed by alkalis. And as a result, once the alkali is destroyed, you get a little sweet scent and aroma of ginger. Now, where all do we use this? So ginger principally has found its application in food, that is culinary, nowadays in medicines, and also interestingly in cosmetics. Now if you see your ginger oleoresin, if you just take the concentrated extract wherein you have those sesquiterpenes and your gingerols and other alcoholic derivatives, the ginger oleoresin offers much strong, pungent, spicy aroma and flavor. And that is the reason if you see in your culinary industries, when they prepare the flavor concentrates, rather than ginger powder, they use ginger oleoresin. Not only that, in your food, whenever you want to add it to your drinks such as ginger ale, you cannot add ginger powder, you need to add an extract. In that case, addition of your ginger resin or ginger oleoresin imparts the desired effect without affecting the clarity or consistency. Similarly, you have your lozenges which contain ginger, and also numerous flavors which encompass your combination of ginger with other spices. In that case, rather than your ginger powder, your ginger oleoresin is being used. Now coming to the pharmacological effects, traditionally and also modern days, we Indians use ginger for motion sickness. So to relieve our nausea, the feeling of vomisis, that is vomiting, this includes your morning sickness, motion sickness, or even for cancer patients, the nausea caused by chemotherapy, your ginger or sunth powder, as we refer to, is a very commonly practiced or used remedy in India for this kind of condition. In addition to that, consuming ginger provides your body with good amount of anti-inflammatory and antioxidant principles, which are beneficial in numerous inflammatory diseases like your bowel disease and also arthritis, as well as numerous wound healing actions have been attributed to consumption of ginger in our diet. Now going on to the next resin. The next resin is a very spicy one, and that's your capsicum. Now capsicum, there are numerous species of capsicum in world, but the capsicum we discuss here is your capsicum minimum or capsicum annum, which is your common kitchen chili. Now this consists of dried ripe fruits of capsicum minimum or capsicum annum, and it's a Solanaceae family member. We often saw your Solanaceae family as the one containing alkaloids. So this is also Solanaceae family member, and this also contains alkaloids. Which ones we'll discuss shortly. Now chilies are grown throughout the world. They are preferred, loved by people for its tangy, spicy flavor that it imparts. The level of spiciness varies geographically and depending upon the species of chilies. Now the most famous chilies come from regions such as America, India, Japan, Mexico, Sri Lanka, and to certain extent China. Now if you see capsicum minimum or capsicum annum, that is our common kitchen chili, if you slit it, you will see that this chili is an outer coating and an inner soft whitish membranous decipiment. Now this decipiment makes or divides the fruit into two compartments, and you will find small kidney shape or what are called as reniformed seeds attached to it. I've kept an image of the seeds of chilies for it, so you will see they are nice kidney shaped, and if you see carefully, the seeds are slightly translucent and you can see the inner spiral shaped embryo inside this. So they are flattened and show coiled embryo in them. Now coming to the composition, the intense pungency of the chili is attributed to alkaloids. Like I said, it's a Solanaceae family member, so it is bound to have alkaloids, and in this case it has amide alkaloids. So similar to your piperine, this is also an amide derivative, but this is much more pungent. So your capsaicin is one of the most pungent principle, and in your capsicum annum it is present to the extent of 0.5%. Now that is responsible for spiciness. The color of chili comes from a set of pigments which belongs to the carotenoid class. A good example of a carotenoid pigment which is present in your chili is your capsanthin. Now in addition to capsanthin, you also have other pigments such as capsorubin. Then you have your cryptocapsin. In some cases your capsanthin and cryptocapsin and cryptoxanthin often are found intertwined and complex to each other or polymerized with each other. You have your beta cryptoxanthin, then you have your epoxides which include your capsanthin epoxides. The yellowness is imparted by zeaxanthin, and in addition to that you also have your beta carotene. So many carotenoid pigments are present, and as a result you will see your chilies as they dry, they become intensely red or deep blood to ruby red in color. In some cases, some chilies, they have so much of this carotenoid that they appear blackish in coloration. So one important attribute of chilies is pungency, and pungency is measured by what is called as SHU, that is your Scoville heat in units. Now Scoville heat unit is one good measure used in food industry to check how much pungent a particular food product is, not necessarily chili but any food product is. So what is done is you take that food product and kind of disperse it in a sugar alcohol or sugar water mixture, and then you see one part of that food how much times you have to dilute. So after dilution I should not be able to perceive any heat or spiciness. So if I am no longer able to detect the heat or spiciness, that dilution is counted as SHU. I'll give you an example. Now in India we have a spicy chili often referred to as king chili or bhoot jolokia. Now this chili is what is called as about a crore of SHU. A crore of SHU, that means you have to take 1 gram of it and disperse it in this much ml, that is 1 crore ml, you can put it in that much. And After that you will not perceive. But if you take the pure active principle, that is capsaicin, it is almost 16 crore SHU. So imagine the spiciness or pungency of capsaicin. The spiciest chili known in the world so far is your Carolina Reaper, which occurs in US subcontinent, and that has about like 1 crore, about 40 lakh, okay, SHU or intensity. Now it is seen that if you want to quantify it, the earlier method is they use a panelist of 5. So if 5 people tell you at this dilution I am not able to detect the heat or spiciness, that was what SHU was. But in modern days, methods such as HPLC are now available. What is done is, we know capsaicin is 16 crore SHU. Then I will quantify in terms of its content, my chili contains how much. So if my chili contains, say 5% SHU, I multiply that and get my SHU units directly. The pungency is now calculated based on your SHU. So not only the pungency, the color of your chilies is also standardized. So this spice traders saw that different over globally, different chili varieties gave you different colors. There was a need to standardize it, and that's where you came across a standard called as ASTA value, which is American Spice Traders Association value, and that uses like a color index method. So that is an ASTA method 20:1. Now what is done is, you take your chili 1 gram and dissolve or extract it in acetone and see the absorbance at 460 nanometers. Now when you see the absorbance at 460 nanometers, your ASTA value is calculated as absorbance into 164 into like your UV correction factor, referred to as IC, and then how much grams of chili you have taken, that is the weight of chili, so or often referred to as your concentration. So it is absorbance by concentration into 164 into your IC. So typically your paprika has an ASTA value, that is the redness value, of 65 to 180. But if you see the oleo resin, like I said, that's going to be more concentrated, and this is also a prepared resin that has a value between 500 to 3500 ASTA units. Now coming to its applications, chili, because of its spiciness, is used in pepper sprays, which have been used in self-defense, crowd control, and it possesses so much of eye irritation, so that if that spray goes on your face is almost numb, watering, painful, and your eyes become temporarily blind. If you use this resin, this is a part of most of your ketchups. So your ketchups, or mostly hot and sweet or spicy ketchups such as your Tabasco sauce, they kind of use or add resins to it. Not only that, the purified compounds, that is your capsaicin and capsanthin, that is the alkaloid as well as the carotenoids, have different applications in coloring as well as in the pharmaceutical industry. Capsaicin in pharmaceutical industry is used in pain management. You use lot of those balms, that is pain balms, and you will see many of them will have capsaicin as an ingredient. So this is useful in management of your neuropathic pain, your muscle pain. It is also used in management of your arthritis. It is used to improve your digestion. It is said that your consumption of chili gives you warmth, and this warmth is beneficial for digestion and to boost metabolism. Now the last oleoresin containing drug that we refer to is your turmeric. Now this is a very common kitchen condiment and spice, known for its brilliant bright yellowness or yellow color. We often refer to as haldi, and it's obtained from the rhizomes of Curcuma longa, often referred to as your Curcuma domestica. This is also a gingiberaceae family member, like your ginger. and it has less spiciness as compared to your ginger, but it's more aromatic, as well as the medicinal effects of its compounds are much fold as compared to your ginger. So turmeric is cultivated in Maharashtra, especially like Erode or Sangli districts, or even in Tamil Nadu. It is cultivated throughout the India, but these are the two chief principal producers and suppliers for turmeric in India. Now, like your ginger, this is also oleoresin, so you can see it is there in your oleoresin cells. So turmeric again is extensively a oleoresin containing drug, where the pigment, that is the oleoresin, is localized in oleoresin cell. It is starchy, and as a result you can see here there are numerous bluish color starch grains which have been stained with iodine, and you can see this yellow color oleoresin cells which contain your yellow pigments. So what are these yellow pigments? So yellow pigments are what are referred to as your curcuminoid derivatives. We'll see a little bit about it shortly. So if you see turmeric, turmeric is a plant again cultivated. Mostly what is done is the fingers of it are cut in a manner very similar to that of your ginger and cultivated in the summer season. Very likely it is in the same like annual plant. It will start blooming, and once the leaves are turned yellow or dried in color, you can dig up the rhizomes. Again, these rhizomes are carefully picked. They are nicely washed to take care of any extraneous matter, and similar to ginger, to prevent any growth or nodes from appearing during the storage time, they are subjected to curing. This curing involves boiling, drying, and in some cases peeling. So this turmeric is exposed to a repeated cycle of heating, boiling, and cooling, and subsequently drying till it acquires a stiff stone-like or very hard consistency. This is what are referred to as prepared rhizomes. Now this prepared rhizomes also contain little black spots or little imperfections, and those are removed by polishing. Now chemically, what we discuss is they contain compounds or pigments. The yellow pigments of turmeric are due to what are called as diphenyl heptanoid derivatives, referred to as curcuminoids. So these curcuminoids are somewhere between your 2 to 9% in your curcuma domestica or curcuma longa, but if you see your other varieties like your lacadong one, you get almost 12% or 9 to 12% of this. So in your curcuma longa, you have your curcuminoids, which are a mixture of three pigments. The principal one, the main one, which makes about 80% of this resin, is what is referred to as your curcumin. Now this curcumin is again what you refer to as a very symmetric dimer if you observe carefully, and this, when you remove one methoxy out of it, you call it as your dimethoxycurcumin. Remove another methoxy out of it, you get what is called as bis-dimethoxycurcumin. So out of the curcuminoids, your curcumin is the major one, consisting almost to about 80 to 85% in some cases. Then you have your dimethoxy, which is a little minor one, about 7 to 9%. Then you have your bis-dimethoxy, which is the smallest or present in the least amount of it. Now when you are taking a curcuma or your haldi, the aroma of it is due to a presence of compound which is your ertumerone. So ertumerone is again a terpenoidal derivative, and this is your sesquiterpenoidal derivative, and if you see your turmeric oil, your ertumerone makes up almost 60% of your essential oil. In addition to that, you also have your alpha and beta turmerone. This only change it from here. So the degree of unsaturation changes and you get your alpha and beta turmerone. In addition to that, you have your gingiberine, philandrin, cineol. It also contains numerous other aromatic principles, which includes your bisacurinone, you have your cordione, you have your bisabolins, curzarine, you have your furanodine, ferulic acid and turmeric acid. Now coming to the applications, turmeric is a very sought adjuvant in cancer therapy, so much so that even pills or medicines or extracts of turmeric have been prescribed for patients undergoing cancer therapy. This includes, or this shows, turmeric shows beneficial effects in patients suffering from colon cancer, lung cancer or even breast cancer. It also takes care of your inflammation, and as a result it's prescribed in your inflammatory bowel disease. Traditionally it is known as antimicrobial agents, wound healing. It is used in cosmetics and also in our Hindu religious ceremony for skin brightening purposes. Now one derivative of curcumin, which is also called as tetrahydrocurcumin. Now curcumin, when you use in cosmetics, imparts a little yellow stain. In order to get rid of it, the double bond of it has been saturated. So imagine if you kind of saturate these bonds, remove this, you get what is called as tetrahydrocurcumin, and this tetrahydrocurcumin is colorless. It has little less in terms of the therapeutic qualities as compared to curcumin, but nonetheless has no staining properties. So in addition to less color, it has enhanced solubility, stability and bioavailability compared to your curcumin. And yes, it has a potent antioxidant, anti-inflammatory, and it can be used for skin healing purposes. So here are a few references if you wish to know more about this set of compounds, and thank you everyone for your patient listening.